write your own functions and, don't actually integrate. Because you could be dealing with functions that maybe, because we haven't learned it yet, you wouldn't be able to integrate like that. And it doesn't really serve any purpose for you to type it into a calculator. So the skill that we're trying to get down here is the idea that you can write an integral that represents a given area. All right. If it's completely above the x-axis, you have no adjustments to make. Really, it's just a matter of what is the integral. You don't have to worry about absolute values or anything like that. So in the case of number one, the only concern would be the change in function. On the interval of 0 to 1, we're working with the function y equals x squared. So this integral will give us this area. And it's almost triangular. If you handed this question to a middle school student and said, what's the area? They would do half the base times the height for each part and not even think about it for another second. Okay? The other part, you could actually do half the base times the height because it is triangular. But it said write an integral or sum of integrals. Right? It didn't say write an integral and like a geometry formula. So this one is going from 1 to 2, and the relevant function, the integrand, is 2 minus x dx. And that's it. So easy. How could it possibly get any more difficult? So looking at number 5, where it gets more difficult, this one only gets, I would say, a smidge more difficult because people tend to overthink it. If you don't overthink it, it's actually the easiest one on the list. Right? No change in function. No change in f of x. That's great, which means that if there is no change in function, it means that I can write a single integral that will cover the entire area. Right? Part of it's below the axis, part of it's above the axis. So there's two ways to handle it. One way would be to say, all right, I'll look at it a piece at a time. I mean, this is not the way I would do it, but sometimes our brains take us in different directions. Actually, this is not the way 2018 me would do it. Like 2010 me would be all over doing it this way. I think 2010 me didn't understand calculus as well, though. So you could do something like this, going from 0 to 2. You got your x squared, your minus the 2x, dx. Then you can go from 2 to 3. Same function. X squared minus 2x. But we have to make a slight adjustment because we know that the red integral is going to bring back a negative result. And I want total area, so I only want positive, so I'd have to go meh. So I'd have to drop any negatives. Now, since I'm writing just an integral, I'd have to use that notation. If I actually wanted an answer, then I could just do some of this in the calculator. I could drop the negative on the fly. But because I'm doing it just for the integral, I would need the notation. The other possible way of writing it, which is a much more convenient way of writing it, would be the integral on 0 to 3, the whole way, of the absolute value of x squared minus 2x. That's what I was going over on the previous page. It's telling us that if we have this graph, and let me see if I can get cute with this for a sec. Lock in place. Let me just move this stuff for a sec. Group together. Get out of the way. I hate you. Snipping tool. Plagiarizer's best friend. Pin to the taskbar. If you don't have a snipping tool pinned to your taskbar, I don't know. Like, are we in the 21st century? Or like, what's going on here? All right, now, oof, let's see if I got what it takes. Custom pen, customize the custom pen. Make it white, thick point. You don't want the round tip pen. Now it becomes a little editor. Oh, maybe you all knew this, or maybe you didn't. Paste it, flip it, and apparently shrink it. Close enough. So, this guy is now the relevant area. And so is this guy. That's what we get if we're looking at the absolute value of x squared minus 2x. And that's exactly what we're looking for. What we wanted to do is to take whatever this area was that's a negative, drop the negative, so make it positive. So find the equivalent positive area that covers the same region, and then add to it the other part that's already positive. So by doing the absolute value of your function over the interval is over 3, we're getting this, which is mathematically equivalent to what we would get if we had a minus. Right. So pretty nifty. It's a nice little feature. And also, in a lot of cases, and this is sort of what we're looking for, it takes a little bit of the thinking out when you're doing the problem. So it means a little bit of thinking now saves you from having to do thinking on the fly. Basically, invent the math now so that you're not trying to invent it during a test. Okay? I think that's the nicest way I could probably say. Because if you're sitting there trying to create stuff on the fly, you've already lost. Okay?